Okay, so in this video, I just want to show you two examples where we can apply the principal component analysis. First one is the gene data. So this first plot shows the first two principal component analysis on the SNP data. It's called single nucleotide polymorphism data. Okay. So the original design matrix has so the sample size here we have is 2,541 people. String data, okay, from all locations of the contains the locations and the SNPs, and each person. So this is called SNP. Okay, for each person, SNP you can think is a binary, a large entries. So it's has a length x. Each person has x1 up to huge. So it's x. So for example, this is 309,790 binary points. Binary vector. So we have the huge dimension of the input, much larger than the even sample size n. And with location, we also have the location of the where the person is born, and this is corresponding the first two components. We can see here UK is clustered with some component here. This and this is the Finland. This is the Poland, and so it's quite amazing to see that with reduction from this huge dimension of the input features with k equal to 2, okay, we can have quite good clusters of these peoples by using only two principal components. Okay, so that's one of the very popular. That's where the gene studies, where the bioinformatics, where people use most, is most important tool they use is the principal component analysis. And the second application is eigenfaces. Okay, suppose you have the images, example 2. Eigenfaces. So suppose now the question is, suppose we have all the picture of the people's face. Now we have each picture has suppose we have the picture here, and suppose we have the 200 by 200 pixels. 200, like a minutes data, right? 200 pixels. So which means we have the 40,000. So the original feature space, we had 40,000 features. So how do we? So the goal of this research is for the face recognition. Because we have the huge dimension of the features, right? So how do we run some classical to identify the people from the picture? Okay, so by running the principal component analysis on these pictures, we can reduce by PCA. We can reduce the feature space D to relative small k. Much smaller dimensions and reduce the computation time. Yes, actually, people just construct the different eigenphase. So this like the this is like the this is like loading vectors for loading vectors for the the arrest data. We can also calculate the loading vectors for the pictures. So that's how we get the first component, second component, third component, up to 31 component. Actually, we can use this loading vector pictures. So by using the 31 features only, we can do the face recognition job pretty well, instead of using the 40,000 features. Okay, so this is another applications of the PCA. I think that's all I want to talk about today. Thank you.